Hi everybody. We are group four, and we have Deming, Lingyun Li, Jiajun, Huang, Ming, Wang, and myself, Liyuan Zhang in our team. And our group project's name is MB Server. Let's first look at data we choose. We downloaded 5 datasets: ranking, players, teams, games, and games details from Kaggle, and there were CSV files. And let's take teams.csv as an example. As you can see, we get every MBA team's basic information in it, like team ID, nickname, and city. So our project consists of 4 parts: front-end, back-end, databases, and Spark cluster. The front-end will be a web app that can display data and interact with users. The backend is responsible for processing HTTP requests from frontend, exchanging data with databases, and also communicating with Spark cluster for computing. We implement EDFS and search analytics using MapReduce. Our frontend displays the results after we explore our databases. This application will help users have a better understanding about the NBA details. For example, user can get data about players and games. And also, user can do searches and analytics about the games data and the games details and teams details in NBA as well. So let's welcome Lingyun Li to present our work in frontend and backend in this project. Let's welcome.
Hi, so I'm Robin, and I'm going to introduce our front-end and back-end code for our whole project. So let's firstly take a look at our back-end code. So for our back-end, we're using Python to write the code. The most important file for back-end is the Ming.Python. The first tools that we're using is a Flask, and it is a tool that connects our front-end and back-end. So it accepts the request from the backend and then make functions on it, and finally send the response back to the front end. And therefore, user can see the results on the front end. Another 4 important files are Firebase, MySQL, MongoDB, and Spark. So we instantiate 4 classes for them. You can see here Firebase, MongoDB, MySpark, and Python. Using MySQL as an example, we have create an initialization function in order to make connections to our local database, and we also create execute command functions to select between different commands, and then deliver to different functions like put, cat, remove, get partition, and we also have search functions and analytics functions on our backend. So that's almost same for Firebase, MongoDB, yeah, and also MySpark. And now let's take a look at the front end. For our front end, we mainly put files in the static folder. So it is image, which is background image to make your front end better. And another file is the HTML file. So HTML file are mostly includes the buttons, search box, tables, and the output box to show the response from the backend. Another file for frontend is the CSS file. And mostly make decorations for the front end and make it more beautiful. And the last important file for the backend is the JavaScript JS file. So it mainly get the object from the front end, and then according to the user input, it make different functions and send a request to backend. For example, for the SQL search function, when it gets the input from the front end, it uses the fetch function to send a request to the backend, and then wait the response from the backend. As long as the response is get, it put the output on the front end. So that's mostly the front end code, and we also have a folder to store the database. So now let's take a look at the front end website for our project. So this is the main page for our front end. The first function is the show file system structure. When user click this button, it will list all the folders in the structure and files for our database structures. And you will see later when we are demoing our database. Another function for the front end is the command search. So firstly, user can select between different database, and then when he select database, he can choose different commands like AOS maker, remove put, get partition, and then according to different commands, we'll demo different input boxes for them. So for example, for this put method, it will need to enter the path, the file name, and the partition numbers. And when user enter all the inputs and click execute, and it will execution these commands and send the output in this result box. And you will see later when we're demoing them. Another important functions for the front end is the search and analytics. When users are selecting one database and he click this search and analytics button, he can see the search and analytics functions. And we also provide the search box for the search method. And when user enter the input and click search, the output will be outputted on the box. And when he switch to different database and then click this again, it will just change according to the selected database. So that's mostly for our front end. So now let's go to the database part.
Thank you, Lingyun. Thank you for your impressive presentation. For our databases part, let's first welcome Deming, and he will talk about our project with MyCircle.
So I'll introduce how our team realized the EDFS command, search, and analytic function in MySQL database. I'll go through the code at first, and then after that, I'll go to the website and do some demo of it. So first, we need to connect to our local MySQL server and create a new database called DSCI551. And we use this database as our MySQL database. It contains two tables initially, which will include all the metadata about the file system and also about the partition itself. The first EDFS command maker, it will basically insert a new row into the metadata table that contains the file path, file type, table name, and partition number. The ls command, it takes in the file path as an argument, and it will basically search through the metadata table to find out and return every element under the path given. And the third function, put, it takes into three arguments: file path, file name, and also number of partition k. Each new data set, the put will create a new table for the data and updates the metadata table by inserting a new row about this data. And this data will also be split into k numbers of partition, and each partition will be created as a new table in the database. And at the same time, the partition metadata table will also be updated accordingly. And next function is cat. The cat function, it will basically read through everything of the files from the files table and returned as a Panda data frame. And the remove function, it will remove its role in metadata and also the files table in the database. And also get partition locations, it will search through the partition metadata table and to find out and return the partition location. Read partition function, it will utilize the cat function to output the data that's stored in the partitions table. And next we have our search and analysis function. Basically, we have map partition to process the data using all the partitions of it. And we have also a reduce function to combine the result together. So our first MySQL search function will do the search on players .csv, and we can get season as the parameter and find out the players according to season. And we basically put the search function into map partition function to let it do a partition-based searching, and then reduce to we use reduce to combine the results. And for our second search function and also analytic function, they also use the PMR technique. And the search to function is basically finding the team IDs based on the season that users input. Analytic function will be to compute the total numbers of player for each season. And next, let's go to our website to do some demo. First, let's switch to MySQL database. And I also opened Workbench to verify our result. As you can see, we have two metadata table in the database right now, and they are currently all empty. And for example, we want to make a directory called user. And we can see our file system here also. Also, we want to create John, Mary under the user folder. And to verify that, we can see our metadata. We have 3 file paths and 3 folder, basically. And we also want to use ls to see if Mary and John are on the user. So we execute. As we can see, it returns Mary and John. And next, we want to validate cat, but first, let's put some real data inside the user. How about teams.csv with 3 partitions? Execute, put OK. Let's put another one, actually. Players.csv with 4 partition. Let's execute also. And let's verify that from our website first. As we can see, we have 2 more files within under user. And you can see we have players and teams with file type as file, table's name, and also number of partitions. And partition metadata, we have the information for each partition. Its location, its table name, and its sequence. And in the database, we have data itself, its partitions, all as a new table within this data set, within this database. And let's try cat. Cat's players.csv. So basically, it will show the contents under this data. And let's try remove. How about remove teams.csv? Execute. Remove OK. Let's see. We don't have teams CSV here. And also we don't have teams in our metadata. And what's next? Let's get partition location for players.csv, which is still in the database. We have 4 partitions for players.csv and under the same folder that players at. And let's read partition for players. How about the second partition? Execute. So this is the second partition, as we can see the index of players.csv. And next, let's do some search and analytics. Find out find all the players after season about 2019. It will return all the names of players for each partition. So this is the result after map. We can see there are, so only partition 1 returns has a result. And after reduce, basically combining all those results, we have all the players' name. And let's try out team ID before season. Before season 2011. And only partition 4 has team ID that are before 2011. Let's try a different one, 2018. And we can see different result. And let's try the aggregate function, which is analytic function. It will return numbers of players by season. And this is the result after reduce from 2009 to 2019. We have different numbers of players of each season. And that's our realization in MySQL database.
Thank you, Deming. That's awesome. For MongoDB part, let's welcome Ming Wang.
Hi, my name is Ming. I'm going to talk about how we implement the emulated commands in MongoDB. Let's first look at an example here. So DSCI551 is our database, and we can see that's how we designed our file systems. We have two special connections, metadata and partition metadata. For metadata, it records the file path of every file in the file systems with some extra information like file type, table's name, and partition number. And this partition metadata is responsible for recording the partition location, table's name, and partition ID for each partition of a specific dataset. And the rest of it, GAMS 1, 2, 3, other connections that store the actual data. Okay, let's dive into code. We implement several functions for MongoDB. We have an initialize function, which just connecting to the DSCI551 database. We have an execute command function to parse the parameters and call the corresponding functions. We have vector, which just inserts one record into the metadata connection. We have ls. We take the path and do a regular expression matching with the path. And then we return all the files that under that path. For put, we have to specify path, file name, and number of partitions. Basically, we have to insert one record into metadata connection. And then for each partition of the dataset, we have to insert one record into the partition metadata to record the partition location, table's name, and partition ID. And of course, we have to insert actual data into MongoDB. For cat, we take the path and we find the table corresponding to that path, and then we return the content of it. Remove is similar to cat. Just take the path, find the table, and delete it. For get partition locations, we take the path and query in partition metadata, and then we get all the partition locations of that path. And for read partition, we use path and the partition ID to get the corresponding table, and then we return the content of that table. We also provide search and analysis functions. We do it through map and reduce. So for each query, we do the operations in parallel for each partition. And then we use the reduce function to aggregate it. Yeah, that's our code. Let's go to the demo part. Let's refresh it. Okay, first we have to check that it's empty in the beginning. We choose MongoDB. First command is make directory. Let's make directory code /user, execute it. It says make dir OK. And then we check out the metadata connection. It has one record /user and its type is directory, which is good. And let's make 2 more directories. Yeah, you can see the user Frank and the user Eric is here. And then let's put some data into the database. Let's say we want to put it under this directory, and its name is games.csv, and we want to store it into 4 partitions. Let's execute it. It says put OK. Let's check out. So in the metadata, we have one more record. The path is games.csv, and its type is file. It's related to this table called games, and it has 4 partitions. And let's go to partition metadata. You can see that we have 4 records, each for one partition. It records the partition location, the table name, and the partition ID. Okay. And then let's get all the partition locations for this dataset. Execute it. You can see that we output 4 paths. And let's say we want to get the content of the second partition. Execute it. Yeah, it returns a table like this. It's actual data stored in the second partition. Okay, we provide a function here called show file system structure, which will output all the directories and files in the database. Let's click on it. Okay, we can see that currently we have user Frank, Eric, and games.csv, which is correct. Let's go to search and analytics part. First, we provide a search function which can find the team's ID, whose free throw shooting rate is let's say 0.4. Search on it. After map, we can see the result for each partition, and after reduce, we can see the final result. This is the team ID, and this is their free throw shooting rate. We have an analysis function which can compute the average score for one team. Let's do it. So after map, we can see the average score for each partition. And after reduce, we can see the final average score, the overall average score, which is 101. Yeah, I think I finished the part for MongoDB. Thank you.
Today I will talk about the file base and PySpark. The first part is file base, and first command is make directory. Make directory is we create the dictionary and put value. Let's show this. First, we make user and John and execute. It shows make directory okay. And we can see it has a root user John. And then ls is easy and as before, so I will just show the put command. The put command is we put in the teams.csv history. This means I get the path, get the file name and the partition number, and let me just execute and explain this. It shows put OK, and we can see from the file-based console, the teams have its own location. It's the whole data, and it will restore to the data node, and it will put 3 partition location, and we can get this location to have access to the partition nodes, the teams partition 1 and 2 and 3. After put, we can see the get partition location, because we put the 3 partition and we can get its location. Get partition and teams.csv. And as we can see, we can get the partition 1, 2, 3's location. And then we can repartition. Repartition is we can put the partition number and the path, and we can get the URL of that partition and read the data inside under partition node, for example. And this partition 3's contents. And we can do the search and analytics. The first find teams by city. For the search and analytics part, we use map partition and reduce. The map partition, we put the function, and reduce, we do the same. The first search is find teams by city. For example, we just put in Los Angeles and search. We can see it's from 3 partition, and only the first partition has the teams, and after reduce, it shows Clippers and Lakers. And let's skip this one and just for the third one because of the time. And we can compute total number of teams by city. This is for analytics. And we can do the search, and we can see only Los Angeles have 2 teams, and other cities have only 1 team. And next, we will go to Spark part. And for the Spark, the Spark is different from the file base. And when we read the CSV using PY Spark, it can just be parallelized and become the RDD. So it's much faster. So we use the biggest data set. And let's do the first search. For this search, we just put the column, put the value, and see all the data that is greater than the value. For example, we type in plus minus and 10. We get all the data that has plus minus, which is greater than 10. And this is the data. We can see it's huge, and only PySpark can do this in a short time. And we can do the analyze part. And the analyze part is just the count of all the data from what we type in. And we can search the game ID, and it shows all the game ID count. And I think that's all. Thank you.